Hello, hey everyone. Nice to meet you. This is Vince from zkLink. This is our first talk inside the Starknet community, and I'm very excited for the progress that we have made together in the Starknet ecosystem. As a part of the Starknet developer community, also as part of the one of the earliest teams building with Carol, we're here to share the recent progress that we have made using Carol language, and also how we aim to unite the ecosystem of Ethereum layer 2s with the Starknet. So I'm going to spend the next few minutes explaining what zkLink is trying to achieve, trying to build here. We are building a secure, efficient, and unified trading execution layer that aggregates liquidities across rollups and also across blockchains. The three major problems we're trying to solve is liquidity fragmentation, which is going to be a bigger problem with the emerging layer 2 ecosystem mature in the future, with this new layer 2 ecosystem become more developed and a lot of new applications with liquidities and also users from abstracted down to different layer 2s. We can imagine that there were going to be liquidity problem, right? So you would have to move liquidity frequently from one to another, and then you either do that through a bridge, either you have the new types of infrastructure like the one we're building to aggregate the liquidities and unify liquidity is easier without using a bridge because it's complex. So the navigation through these different ecosystems is complex and it's not user-friendly. And also there's a security risk associated with bridges. Some of the features that we're building onto the protocol are like we want it to be easy for developers to use. So we're building this, we're offering high-level APIs for developers to quickly deploy their applications and with native access to multiple blockchains, multiple rollups. And we're allow users to customize the APIs, customize the features, customize their needs for data availability, customize their needs for network collections. I'm going to extend to that later on. And we can support several types of use cases, but they are all focused on they are all basically trading focused. For example, club, central limit order books, RWA derivatives, NFTs, AMMs. So this is a graphic that can give you a very rough overview of the network structure of zkLink protocol. There are several types of applications that we support, and then within each of the zkRollup network deployments, there could be one to several applications using that setup. For example, one application can choose to deploy on Ethereum being the chain Starknet, which represents Ethereum to solve and Ethereum rollup VM and EVM compatible auto layer 1. And another application may choose to deploy solely on Ethereum rollups, like optimism rollups and zk rollups. And another application can choose to solely deploy on Ethereum zk rollups, like Starknet zkSync, other zk EVMs. But they among all these different setups and deployments, they can share the service through a recursive verified contract, so they can share the cost of generating a proof and verify the proof. The types of networks that we support, we have briefly explained, including Ethereum layer 1, EVM compatible blockchains, even layer 1 EVM incompatible blockchains like Solana. We have completed the Gross 16 proof contract on Solana, but we have post work there. Since they do not support SHA-256 for Plonk proof verification. And we also support zk EVMs. We're live on zkSync and Linear, and we're working on Polygon zk EVM and Scroll, Tyco, etc. And also we have included OP rollups as well. And we have just launched the testnet on Starknet, which represents zkRollup VMs, EVM non-compatible. For developers, they can choose their deployment of network collections among these three types of networks that we support. we have highlighted here the zkRollup VMs deployed on this Ethereum mainnet because our thesis is very much Ethereum-centric. We believe that the future of blockchain will be, especially the DeFi applications, will be Ethereum-centric. Most of the liquidities will be staying on Ethereum and Ethereum rollups. So we'll be moving from where we are today, the deployments of outer layer 1s plus layer 2s, which will make us a hybrid model of layer 2.5. And we're gradually switching to a layer 3, multi-rollup layer 3. So we'll be settling transactions on layer 2s, including Starknet. This is one example of network collection scenario that the application could choose. And here you can see that this application chooses to deploy on the BME chain, the Ethereum, Starknet, and the validator, prover, and sequencer system, the off-chain services will be posting the proofs to the contracts deployed on each of these different networks. And then as you have like outer layer 1s, then they cannot directly talk to Ethereum, then you need like third-party independent light oracle services to synchronize the states through the final routes. As this validator system is posting the proofs to different chains, and then you need like independent service to synchronize the states of these state routes to mitigate the risk of conspiracy, because you don't have to trust any a validator system or other chains, but with the help with the light oracles. These light oracles can be any generic messaging service like layer 0, Chainlink, or you can be some stakeholder in the ecosystem like a market maker. They can run the program themselves as well, so they don't have to trust anyone in this system. I just mentioned that we also provide customizable solution for DAs, so application can choose to deploy their data availability to one of the networks they connect to. We call it the internal DA. For example, one application has deployed on Ethereum, Polygon, Starknet. They can choose one of these three to store the data to perform as a DA. And also some external DA like Eigenlayer, like Celestia. And also they can store the data off-chain. Starknet has talked about like a data community off-chain. Well, this is one of the options. And also it can be a mixed model between these two. There are some roles of in the zkLink ecosystem: user of the applications, application developers, and community participants, including validators, provers. I think you are all very familiar with this because any zkRollup has these roles in the ecosystem. And we will going to decentralize the validators and the provers also in the zkLink ecosystem by through a token incentives, and also zkLink core contributors that are right now developing and iterating the codes. How developers can use zkLink protocol is they can simply just deploy their applications by using the APIs, by calling the APIs. And on the website there are detailed examples and instructions of how to use these APIs. And for customizable deployments for some specific requirements from features, for example, an order book desk may certainly wants to build some specific financial features which they need help of the core devs to realize or to build those features into the circuits. The devs are writing the circuits using RCES, so very low-level language, machine language, to build the circuits. And the circuits is certainly smaller compared with generic zkRollup like Starknet. And these types of orders and these types of opcodes of this written by RCES is more efficient, much more efficient compared with the opcodes built by a higher level language that we ultimately interpreted into Solidity, into Cairo, and all other languages. The reason we're doing this because we want to build these trading specific features that will be more powerful and efficient than that you could do using a generic language. Otherwise, it won't be competitive. And right now we support the functions of spot trading, derivative trading, perpetual contract, OFT minting trading. Very soon in Q4 this year, we'll have NFT issuance trading and RWA derivatives covering different asset class. And some of the recent updates of the project, we have performed the first ever in industry the asset recovery test on the layer 2 level. This is showcase the real security boundaries of any layer 2 networks. We have done this in May this year, and there are over 100,000 zero-knowledge proof generated. And yeah, we helped more than 50,000 users recover their funds on our testnet using the data stored on chain. We stored the data on Polygon for that test. And we also have conducted several rounds of security audits of all the smart contracts and also the zero-knowledge circuits. And we launched the Alpha Mainnet just last month. And right now, users can deposit and withdraw native assets enabled from different 10 mainnets, including Ethereum, Starknet. So our journey on Starknet began in June last year. Our devs started developing the contracts using Caro 0 last year. And then we deployed the contract V0.1 on Starknet's testnet August last year. And then we started to upgrading the contract from Caro 0 to Caro 1 this year in May again, since there's an update of the language. And now we just completed the migration from Caro 0 to Caro 1. The V2 smart contract is live on testnet right now, so users can use the Starknet testnet. And we expect to go live in September on Starknet mainnet. The migrated EVM contract to Starknet can enable interaction between other EVM rollups layer 1 chains with Starknet. And we have developed a specific feature we call bytes. It's similar to the bytes feature in the Solidity language. This data structure is to facilitate the Solidity to Caro migration. We will very soon open source this for other developers. And there are some other active contributions to Caro development from our devs. Well, I'm not going to spend time on this anymore. But well, this is like a little bit more detailed explanation of our work on bytes. So in Solidity, encoded packet used to design complex types of hash functions. Because to realize the Planck proof verification on Starknet, we need to enable two functions. One is kcac, and another one is called SHA-256. These two hash functions using the Caro language is not very difficult. So our devs have developed this specific data structure to enable these two functions to verify the SNARK Planck proof. Well, this is some details of bytes. It's a dynamic array of U128, each element containing 16 bytes, extensible to 31. The byte size is adjustable based on dev community feedback for most needed use cases. And we have used this to enable easy kcac 256 hash calculation for token type structures in both Solidity and Caro. On a very high level, we want to provide an infrastructure solution that makes it easy for DEX developers to build scalable and secure applications on multiple blockchains and multiple rollups, especially rollups. We're gradually shifting from multi-chain to multi-rollup layer 3. And considering the future, this is a very simple graphic showing the layer 3 structure of zkLink or multi-rollup. We're going to post the proof, state proof, where the zkLink off-chain service have a unified state tree to record all transactions across different ecosystems. And then the validator is going to post the proofs together with the state proof to different layer 2s zk rollups, like including obviously Starknet. And then the contracts of these layer 2s will post this message to Ethereum through the official bridge service, and then settle ultimately all these funds and transactions on Ethereum. So everything ultimately is settled on Ethereum and secured by Ethereum. So it achieves the same level of Ethereum itself. there's no absolutely no compromise and degradation on security in that sense. But still, through this, we'll be able to abstract and aggregate liquidity, unified liquidities across all the zk rollups. Yeah, so pretty much zkLink is working for a rollup-centric multi-chain era that we believe is coming very soon. And we enhance the layer 2 ecosystem by unifying liquidity, by simplifying cross-rollup user experience. And our aim is to add value and unite the Ethereum ecosystem with zk snarks. So yeah, we're happy to explore more synergies with all the ecosystem projects. Thank you very much. And we're running a summer tour to help users to explore different layer 2 ecosystems. And if you're interested, you could take a look here. And thank you very much.